Hello everyone. Welcome to the next lecture on the orthogonal and orthonormal vector. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can find the playlist of the numerical linear algebra. In this playlist you can see the various lectures such as Gram-Schmidt process, condition number, Jacobi method and many more lectures available in this playlist for you. You can watch and subscribe my YouTube channel. Now what is the objective of this today's lecture? We will try to learn what is the concept of the orthogonal vectors and the concept of the orthonormal vectors. First of all, the orthogonal vector is a very important topics in the linear algebra. We all know if you look about these real, if you call as the x-axis and the y-axis, fine. And we all knows the x and y-axis are perpendicular to each other. Fine, they are perpendicular to each other. So the same concept we can utilize in terms of the perpendicular to the orthogonal vectors. Orthogonal vectors are those vectors which are perpendicular to each other. Or in other words, you can say the two vectors are said to be, remember we are talking about the only two vectors. The two vectors are said to be the orthogonals if their dot product is 0. That means you can say the two vectors are said to be orthogonals whenever they are perpendicular to each other. Or in other words, you can say the orthogonality is the generalizations of the perpendicularity, because perpendicular you can always talk about the two vectors. But what will happen if you have the three vector v1, v2 and v3? Then it is not easy for us that we can define the perpendicular between them. So in order to address the perpendicularity to more than of the two vectors, we can utilize the concept of the orthogonality. What is the meaning of that? First of all, we can define few definitions. Like first definition is the dot product. How you can define the dot product of the two vectors x and y, which is the first element is multiplied with the first element x1 into y1 plus second element is multiplied with the second element x2 into y2 plus third element is multiplied with the third element, last element is multiplied with the last element, and that is the definition of the dot product of the two vectors x and y. For example, and when you can say these two vectors are said to be the orthogonal whenever x dot y is my 0. Or in other words, if you write in terms of the matrix, then you can say the x transpose into y is my 0. How you can calculate them? For example, can you calculate the x dot y? So first component multiply with the first component, that is 1 into minus of 2 plus second component multiply with the second component plus third component multiply with the third component. The answer will be minus of 2 plus 0 plus 3, that is my 1. Fine. Always remember students, whenever you are trying to calculate the dot product, this answer will always be the scalar. Scalar means that is a single element you can always observe after calculating the dot product. Another definition which we are needed to understand the concept of the orthogonal is the length. How you can calculate the length of the vector? For example, if you have, again, say this is my x, this is my y, any point here, say for example 1 comma 2, then how you can calculate the length of this vector? If I say this is OA, then the length of this vector OA I can define. If I say this number is my x, then the length is defined by norm. This is called as norm of the x. Fine. And which is defined as root of the component 1 square plus 2 square. That is a component of the x1 square plus x2 square and so on. That is the length of the vector. Make sure whenever this length, as I mentioned you, if you consider the vector is 3 comma 4, then how you can find the norm? That is 3 square is 9 plus 16, that is a 25, root 25 is my 5. Make sure students, whenever the length is my 1, then you can say the vector x is the unit vector. Whenever the norm of the x is my 1, then you can say the vector is said to be unit vector. On the other hand, if norm of the x is not equal to 1, then you can convert any vector you can convert any vector to the unit vector. And how you can convert them? That's a very simple. You can divide it the vector x by its norm. Then the length of this vector is my 1. Now, for example, again, if I consider this vector is my 3, 4, then clearly say what is the norm of this x? It will be 9 plus 16, 25. 25 root is 5, which is not equal to 1. Then how you can make them into the unit vector? The unit vector is x divided by, x is my 3, 4 divided by norm is 5. So which becomes 3 over 5 and 4 over 5. Because this is the unit vector, so they are writing in the direction of this vector u. Fine. Now, based on these two definitions, that is a dot product and the unit vector, we can define the concept of the orthogonals and the orthonormal. If we have v1, v2, v3 up to the vn is the n vector, then we can say these vectors are said to be the orthogonal whenever vi dot product of the vj is my 0 for all I is not equal to j. Fine, that is a dot product. We can say the dot product between the any two vectors is my 0 provided I is not equal to j, then we can say this is the orthogonal vector. On the other hand, when you can say the orthonormal, the first one is it must be the orthogonal, that is the dot product will be 0 for all I is not equal to j, and the second is norm of the each vector vi is my 1 for all I. Whenever these two properties are satisfied, then you can say this is the orthonormal. Otherwise, if any one of them is not satisfied, then it is not orthonormal. For example, if you look about these two vectors v1 and v2, if I check whether they are orthonormal or orthogonal. So firstly, we can find the dot product. First element with the first element, second element with the second element, third element with the third element. So that will be 0. So we can say v1 and v2 are orthogonal vectors. Fine. These are my orthogonal vectors. Clear? Now, is it the orthonormal? We can calculate the norm. Norm of the V1, which is defined as 1 minus of 2 square is 4, is a 16, which is clearly is not equal to 1. So therefore, V1 and V2 are not orthonormal. They are not orthonormal. Clear? Look at the second example. If I consider this is my V1, this is my V2, this is my V3. So can you find the V1 dot V2? First element with the first 1, then minus of 2, then plus 1. This is 0. Can you find the V1 dot V3? V1 dot V3 is a 1. It's a minus 1. It's a minus 1, which is equal to minus 1, which is my non-zero. And since one of the element is my non-zero, we can say the given vectors are not orthogonal. Fine. They are not orthogonal because the V1 and V3 are. So once they are not orthogonal, you can say they are not orthonormal. Fine. Once they are not orthogonal, they will never be the orthonormal. Look at this vector. Check whether the vectors are orthogonal or not. So we can find v1 dot v2. We can find v1 dot v3. We can find v2 dot v3 for the orthogonal vectors. So can you find the v1 dot v2? First element with the first element plus 0 minus 1, which is my 0. v2 dot v3 1 minus of 2 plus 1, which is again 0. v1 v3 1 minus of 0 minus 1. 1 minus 1 will be 0. So yes, v1 v2 v3 are my orthogonal vectors. Now how you can check about the orthonormals? We can calculate the norm. Can you calculate the norm of v1, norm of v2, norm of v3? If all are my 1, then you can say yes, this is orthonormal. If at least one of them is not 1, then you can say they are not orthonormal. orthonormal. So let's start with this V1. It will be 1 plus 0 plus 1, which is equal to root 2, which is not 1. Similarly, you can calculate the V2. Norm of V2 is 1 plus 2 plus 1, which is 4. That is my 2. Again, they are not equal to 1. And similarly, for the last case, it is 1 plus 2 plus 1, which is root of 4. That is my 2, which is not equal to 1. So therefore, they are my not orthonormal. If at least one of them is not equal to 1, then you can say they are not orthonormal. Now, a very important point for all of you, very important. Whenever you have a orthogonal set, fine, orthogonal means, again I can recall you, vi dot vj is 0, fine. Once you have the orthogonal set such that norm of the vi is not equal to 1, that means they are not orthonormal, then you can convert this orthonormal set into the orthogonal set into the orthonormal set very easily. Fine. Then you can easily extend it the orthogonal set to the orthonormal set. Make sure, what is the property of the orthonormal? You have your targets to prove that norm must be 1. How you can make them is a very simple. If I say vi dot vj is my 0 in the case of the orthogonals, then in the case of the orthonormal, your target is to prove the norm is my 1. So I can divide it any element or any of the vi divided by its norm so that it becomes my orthonormal set. That means if you have the v1, v2, vn are the orthogonal sets, first of all make sure it must be orthogonal. Then you can say we can construct the orthonormal set by dividing it into norm. अगर बच्चों वो orthonormal set नहीं हुए तो फिर आप ये definition use नहीं कर सकते आप. Fine. So whenever they are not orthogonal, then you can never make them as a orthonormal by using this definitions. We can use them by using a Gram-Schmidt process, that is a later on. For example, here, as we can see, verify whether they are orthogonals. This is the same example. So that means v1 dot v2, v1 dot v3, and v2 dot v3. We can easily see the dot products are my 0. That means they are orthogonals. But we can see what is the norm of v1. Norm of v1 is my root 2. Norm of v2 is my 2, and norm of v3 is my 2. So that means they are not orthonormal. Fine. But because they are my orthogonal set, so I can easily convert these v1, v2, v3 into the orthonormal. And how you can convert them? That is by using calculate the norms, v1 divided by norm, v2 divided by norm, and so on. So how you can calculate the norm? This is the same example of the previous. That is 1 plus 0 plus 1, which is my root 2. Similarly, norm of v2 is my 2. Norm of v3 is my 3. I can substitute the value. What is the v1? 1, 0, minus 1 divided by norm. That is root 2. So I can say this is 1 by root 2, 0 minus 1 over root 2. Similarly, what is the v2? v2 is my 1, root 2, 1, and norm is my 2. So I can write this number is half root 2 divided by 2 and half. Because this is a column vector, so better you can write as a transpose. Fine. You can write it as a transpose. Similarly, what is a v3? 1 minus root 2, 1 divided by 2. So this will be 1 over 2 minus root 2 over 2, and half are the orthonormals vectors. Fine. And you can check also this answer whether they are orthonormal or not. How you can check your answers? If I call this number is say my u1, this number is my u2, this number is my u3. How you can check whether they are orthonormal? You have to check the two properties. Ui dot uj is 0, and second is norm of each of ui must be 1. And clearly say if you take u1 dot u2, what will happen? It is 1 by root 2, 0, minus 1 by root 2, 0. Similarly, you can check that u1 dot u3, again 0, u2 dot u3 is again 0. Also, you can check the norm of u1. It is root of, it is 1 over 2 plus 0 plus 1 over 2. It is my 1. Norm of u2 is, so 1 over 4 plus 2 over 4 plus 1 over 4, which is my 1. Similarly, you can find the u3 norm. It is again 1. So now, because you can write in the form of the set, you can write the first vector, comma, second vector, comma, third vector in the form of the set. Verify that whether the vectors, I call this vector is my v1, vector v2, this is v3, is the orthogonal set. So that means your target is to prove v1 dot v2 is 0, v1 dot v3 is 0, v2 dot v3 is 0. Fine. So let's start with the v1 dot v2. First element with the first element 0, second element with the second element, third element with the third element, and 0, which is my 0. v1 dot v3, 4 minus 4 plus 0 plus 0, which is again 0. v2 dot v3, second element, first element with the first element, minus 3 minus 4 is a 12 plus 12, 0 minus 6 and 2, so that is my 0. So therefore you can say the vector v1, v2, v3 are orthogonal vectors. Now use it to construct the orthonormal vectors. Fine. Now once it is orthogonal vectors, yes, you can construct the orthonormals. We can calculate the norm of the v1, we can calculate the norm of v2 and norm of v3. So can you calculate the norm of v1, which is root of minus 2 whole square plus 1 square plus 3 square plus 0. So that comes to be root 14. Similarly, for the second v2, 0, 9, 1, 36, that comes to be 46. And for the last case, it is 4 plus 16 plus 0 plus 4, that comes to be 24. Hence, once you can compute it, so therefore, orthonormal, first of all, are the orthonormals? Is the set S is orthonormal? Can you say is the S is orthonormal? No, because they are not equal to 1. Fine. If they are not equal to 1, that means S set is not orthonormal. And it is orthogonal, so we can construct them. How you can construct them? V1 divided by norm of V1. V2 divided by norm of V2. V3 divided by norm of V3. So we have computed the V1 norm of the VIs, and we can substitute the values, which comes to be minus 2130 divided by root 14. Similarly for the second, similarly for the third are the orthonormals set. Look at the next one. Verify the functions are orthogonals over C0. The C means the continuously differentiable function. Fine. So if you have the two functions f and g, we can define the norm of this will be from a to b, f into g. That is the definition of the inner product space of the C minus pi to pi. Now we have to check whether they are orthonormal or not. In this case, instead of the V1, V2, V3, they are F1, F2, F3. So my target is to check what is the dot product of the F1, F2, F1, F3, F2, F3. So can you find this value? It is from minus pi to pi. By the definition, it's a product F into G, that is F1 into F2. F1 into F2 is sin x. Similarly, for the second case, it is from minus pi to pi, F1 and F3, that is a cos x. And for the third case, it is minus pi to pi sin x into cos x. Fine. Now, can you find the integration of sin x? Sin x will be minus of cos x from minus pi to pi. It comes to be 0. Why? Because you can see this number is my cos of pi minus cos of minus pi is my always positive. Cos pi minus cos pi is 0. Therefore, f1 dot f2 is 0. Similarly, you can write the integration of cos. It will be sin x from minus pi to plus pi. So that will be sine of pi minus sine of minus pi. Sine pi is 0. Sine of minus is plus. So again it is 0. So second answer is also my 0. How you can write the integration of the third part? I can multiply 2 and divide it by 2. Fine. So this is my sine of 2x. Fine. Now you can integrate them. It is half. It is minus cos 2x over 2 from minus pi to plus pi. And clearly say it's a minus 1 over 4 is outside. So it's cos of pi minus cos of minus pi. Cos of pi will be my 1. So it is 1 over 4. Cos of pi is my minus 1. Again, it is a my minus 1. Fine. So it will be 0. So cos pi and cos pi will be 0. So that is again answer is 0. So therefore, all these inner products or the dot product is 0. Hence, the given functions are my orthogonal functions. Now, once they are orthogonal, yes, you can construct the orthonormals. So, but before that, you need to compute the norm of the f1, f2, and f3. So norm of the f1 will be, so it is root of, the definition is minus pi to plus pi. That is a f into f square. Fine, that's a 1 square. So can you find the integration? So that will be, it's a 1. So it will be 2 pi. Similarly for the f2, f2 will be integration of minus pi to pi, f2 square, that is a sine square x. f3 will be cos square x. The answer of first part will be integration is my x from minus pi to plus pi, that is my 2 pi. The first part is 2 pi. How you can solve this integration? So integration of the sine square x. How you can write the sine square x is 1 minus cos 2x over 2. Now once you can integrate them, it will be half is outside, x minus sine 2x over 2 from minus pi to plus pi. So if you substitute them, if you substitute pi, it's a pi. Sine of 2 pi will be 0. Minus minus plus pi. Sine of pi will be again 0. So it is my pi. Fine. 2 pi, 2 will be cancelled. It is my root pi. Similarly, you can compute this number. Again, you will get the answer as root pi. And clearly say these numbers are my not 1. Therefore, the given set of the functions, if I consider the set of the function is f1, f2, f3, they are not orthonormal. Fine. But the set is orthogonal. फाइन ऑर्थोगोनल है लेकिन ऑर्थोनॉर्मल नहीं है, तो हम क्या कर सकते हैं, ऑर्थोनॉर्मल को ऑर्थोगोनल को ऑर्थोनॉर्मल में कन्वर्ट कर सकते हैं बाय यूजिंग द डेफिनेशन f1 डिवाइडेड बाय नॉर्म ऑफ f1, f2 डिवाइडेड बाय नॉर्म ऑफ f2, f3 डिवाइडेड बाय नॉर्म ऑफ f3 is the set of the orthonormal vectors. Now make sure students, मैं बार बार कह रहा हूं, in all these examples we have extended the given set of the vectors to the orthonormal only they are orthogonal vectors. That means if your given set of the vectors are not orthogonal, that means vi dot vj is my non-zero, then we can never write as the orthonormal set by using this matrix format. Fine. So, but we can write that, for example, you can see v1 dot v2. What is the v1 dot v2 is? Minus 1 plus 8 plus 6. That give you 13, which is my non-zero. Once they are non-zero, that means you can say the v1 and v2 are not orthogonal. Fine. So once they are not orthogonals, then you can never write the orthonormal by using this format. But how you can write this again, but still you can write as the orthonormal vectors. But in that case, we will use the concept of the Gram-Schmidt process. For that case, you can watch about my this lecture, KUR factorization of the Gram-Schmidt process. I will upload the Gram-Schmidt process lecture as a separately as well. But till now, make sure that's a very, very important property. Once they are not orthogonal, then you can never write as the orthonormal vector in this format. But you can write it as the orthonormals vectors by using the process of the Gram-Schmidt orthogonalizations here. Another very important property of the orthogonals is they are always linearly independent. That means if you have V1, V2 and Vn, they are my orthogonals, fine. Then you can directly say V1, V2 and Vn are my linearly independent sets. That's a very, very important property of the orthogonal. That means orthogonal set of the non-zero vectors are always linearly independent. Fine. The proof is a very, very simple. You can write in a very line. For if I recall you, how you can prove the LIs? If I say V1, V2 and Vn, when you can say are said to be linearly independent. This is said to be. When you can say they are said to be linearly independent if there exist alpha i's such that if you multiply them alpha 1 v1, alpha 2 v2 up to alpha n vn is 0, and if you prove that each of the alpha I is my 0, if you prove that each of the alpha I is my 0, that implies vi's are my li. ऐसे तो प्रूफ करते हैं ना मैं li को. So the same way we can start from here. So remember that. What is the meaning of that? They are my orthogonals. What is the meaning of the orthogonal is vi dot vj is my 0. Now, in order to prove the LIs, I can assume alpha i's are my scalars. How you can prove the LIs? We can assume alpha 1, alpha 2, alpha r are the scalars such that their number is 0. Fine. Now, let's say this is my equation number 1. Now, I can multiply, fine, because these are my non-zero vectors. So, I can multiply the equation number 1 by V1. Fine. So, what will happen? It will be V1 dot alpha 1 V1, alpha 2 V2 and alpha n Vn, which is equal to V1 dot 0. Fine. Now if you open them, alpha 1 is a scalar, so that's a V1 dot V1 plus alpha 2 is a scalar, V1 dot V2 plus and so on. Alpha n is a scalar, V1 dot Vn, because 0 is my 0 vector, so if you multiply them it is my 0. Fine. Now you can see what is the value of the V1 dot V2, that is my 0, by using orthogonal property. V1 dot Vn is again 0 whenever I is not equal to j. So therefore the only expression becomes, fine, which is my 0. But make sure student V1 dot V2 is not always 1. Is not always 1. ये 1 कब होगा? Once they are orthonormal. क्या स्टेटमेंट में कहीं orthonormal बोला है? No, they are only set for the orthogonals. Fine. So, but we can see they are my non-zero vectors. Can you find the value of the alpha 1? Alpha 1 will be 0. Fine. So, because V1 dot V1 will be 0. Similarly, I can multiply the equation number 1 by V2. Then we will get alpha 2 is 0. We can multiply by V3. We will get the alpha 3 0 and so on. So in general, we can say all of the alpha i's are my 0. Once all the alpha I are 0, therefore the given set vectors are my linearly independent. Now, these are these few exercises for you. Can you solve all these 4 problems and check whether they are my orthogonal vectors or orthonormal vectors? If they are not orthonormals, you can convert into the orthonormal vectors by using the stated methods. Let me know your answers in the comment box. I will wait which of the followings are my orthonormals or not. Very soon we will upload the next lectures on the orthonormal basis. Till then, you can share this video with your friends. You can like and comment on the videos. Happy learning, students. Thanks for the watching. Best wishes.